It has been some time since we last did any sort of graphic stuff, but we are hopping right back into it with a new sort of project. So this is not going to be 3D, I'm going to tell you, and this is not going to be using any of the code that we have previously written. This is a completely new series. So we're going to be building it from scratch, which is going to be interesting, but also a refresher because I've learned a lot in writing the other tutorial, or in doing the other tutorial, so this will be maybe more informative. I don't know, but we will we'll just have to see. So this is in this series we're going to be creating Pong, so you know, your classic Atari game, and it's going to be 2D, so there will be a softer learning curve, or a shallower learning curve into getting into this stuff, although there will be still some of the same concepts, the VBOs, the VAOs, and we'll get into what all that actually means. So this will also be somewhat of an OpenGL crash course, so we'll be looking through many of the functions, this, that, whatever, blah, 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 whatever, and then we'll be looking at how to actually format that into a game and connect it all into a game. So today I just wanted to go over setting up our environment, so our IDE, and the instructions are right here, so it's going to be pretty similar to the first OpenGL tutorial video, which I have in this playlist. And then we're going to be creating a very simple 2D engine, and not really sure how far we'll get because I do have quite a bit code planned, but you know, I've been droning on for 2 minutes and we haven't even said anything valuable. Okay, so let's just go ahead and get right into it. So in Visual Studio, well, I'm just gonna, whatever IDE you have, go ahead and create a new project. The instructions here in on the GitHub follow Visual Studio, so if you can do that if you want. So I'm going to create this in, what's the path to this? Did I even, oh, I did clone it, no way. Alright, so I'm going to put it in here. Alright, so I'm just going to create a new project with that C++ empty bare bones, and just letting you guys know this will be more bare bones than last time. We're going to be using only 2 libraries this time, GLFW and GLAD. I believe we're not going to be using GLM, simply because we don't need to do much math. It's going to be a simple projection matrix, and we'll be able to create that on our own. Alright, so let's go ahead and just do our classic hello world. So create just a main.cpp, and I'm already going to see, I already know that by the end of this I'm going to receive some hate because this is all going to be in one file. There's going to be no sort of organization whatsoever. It's going to be plop all in a singular file. Some people might like it because it's simpler, but others might absolutely detest it. But it's going to be not too much for today. So just like that, and then we'll run this. Make sure you are in x64 when you run this, by the way, just so we can kind of you know, figure that out. All right. Okay, so now we actually have to get into installing stuff. So I've already pre-installed all this stuff, but I'm going to set the properties now with you guys. So in the properties window, first go into linker, input, and then in additional dependencies, add the title OpenGL32.lib. Oops, oh no, you know, guys should not be seeing that. Alright, here we go. So OpenGL32.lib, and then add a semicolon at the end there, and click apply. Now find the downloaded stuff. I'm going to go ahead and copy and paste it into here where my stuff is. So, and I'll make this larger so you guys can see this. So in my solution, I'm going to create a new folder called linking, and in there I'll have an include and a lib. Oh, not include, include. And then in the where is it? In the include directory, what you want to do is here, I'm just going to open up both of them at the same time. So open a new window, here, view as large icons. Alright, so I'm in my linking directory on the right, and on the left side I have my packages. So go ahead and take all this stuff here, and I'm doing GLFW right now, and take the include directory and go inside the include directory and drag the GLFW folder and copy it over into the include directory. And then in the lib, you want to find your corresponding compiler. So for me, it's VC 2019, and just take only the GLFW, both .lib folders. So go ahead and copy those there. Next, what you want to do is go into where your source files are. So where your main.cpp is, and copy and paste the glfw3.dll file, because that's the source code library that we will be needing to actually compile the GLFW code. Now, alright, so that's all of GLFW. Now for GLAD, pretty similar, so just open that up. Go back into your linking directory. In the include, same process, just drag the two folders in, copy them, and then in the lib, we actually don't have any library folders for the for the GLAD stuff. Okay, and then but we do have a source file that you'll need to drag to the same place as your source code. So where the DLL file is, just drag the glad.c file to. So copy it over. Alright, so now all the files are there. Now we have to set the properties. So in the linker, so go back to your project properties, go to linker general, and then in additional library directories, you are going to add this path. So it's put explicitly on the installation instructions. So just go ahead and you can copy and paste it over. Oh, wait, did I? No, that's right. So that goes in there. So it's the $sign and then in parentheses solution dir, close parentheses / linking / lib. So just the path to wherever you put your library files. So go ahead and click apply, and then in input we just want to include that GLFW library. So we're going to say GLFW / glfw3.lib, I believe is what it's called. Lib glfw, and yeah, so just the path from this library folder to wherever the .lib file is, and then make sure to put a semicolon after it as well. Alright, click apply. Now go into your VC++ directories, and in include directories you want to add the include directory that I have put on the installation instructions. So it's just wherever you put the include folders. So just like that, and then a semicolon, and then for the library directories you just want to copy that over once again. I believe that is all we need to set up for now. So click apply, click OK, and we should be all good. Alright, so wow, it's been 10 minutes and we haven't done jack shit. Alright, good. Let's start typing some stuff down. Alright, so back in main.cpp, everything should be all set up, so we can go ahead and just get right into writing the code. So at this top, we're going to have our includes first. So we're going to start by including glad/glad.h should show up on IntelliSense, and then include GLFW/glfw3.h. So these are the only libraries that we need. And then below that, you want to include IOStream, include string. You want to include SStream and include FStream, because we will be reading some files here. God, this fucking, I've missed this, holy shit. I'm gonna get all nostalgic right now, but it's only been like not even a month since we last did some OpenGL, but it has been a little bit since we've listened to this album, and god fucking damn it, it gets me every time. It actually has been more than a while since I've listened to this album, like dedicated by itself, so I'm tearing up over here. Okay, so we'll start by declaring some variables for settings. So just settings, we'll have an unsigned int scr width is equal to 800 for now. Unsigned int scr height is equal to 600. And then const char star title is equal to Pong. Now we're going to, so what I'm going to start doing is, I'm just going to create some function templates first, and then we'll write our main method code using those templates, or not templates, sorry, definitions, and then we'll write the actual function bodies. So we'll get the framework out of the way, and then we'll actually fill in the blanks for that framework. So what happens at each of the steps that we want to define. So what you will notice is that this is pretty similar to some of the OpenGL tutorial code that we wrote, specifically the scene code or the GL memory code, except we're not going to be using any object-oriented programming just yet. Well, I actually don't know if we will this tutorial, but it's a smaller program. It only needs so few basic items. We'll need some VBO stuff, VAO stuff, and then a little bit of screen functions, or a few screen functions, but not much beyond that. So we're not going to be importing any 3D models, or we won't do images just because that's Pong. It's pretty simple. So we're just going to be keeping it to the simpler stuff for now. We could make a 3D Pong and make it super cool, but we'll leave that for next time. That's actually a cool idea. Create 3D Pong where your POV is the paddle. That'd be kind of fun. Alright, getting off topic. So we'll start with our initialization methods. So here we'll just set up the environment during the compile or the runtime. So first one is initialize GLFW. So void init GLFW. We're going to pass an unsigned int version major and unsigned int version minor. Empty body. We want to have a create window function. So void create window. And for the first parameter, we're going to say GLFW window pointer and then a reference to that pointer window. Then const char star title, unsigned int width, unsigned int height, and then the last parameter will be our callback. So this is the type GLFW frame buffer size fun. So short for frame buffer size function. That's just my computer. Got the Outlook mail. And then just say frame buffer size callback. Just like that. Every song. God damn it. Next one will be that callback. So callback for window size change. So void frame buffer size callback, GLFW window star window, int width and int height. And then finally we want to have a function to load glad. So load glad library. So bool load glad. Just like that. So these will all be functions that will allow us to set up the environment for OpenGL to actually be run as a library. We'll be connecting all the libraries, we'll be creating the window, setting the viewports, setting the window as the primary window, and establishing the pipeline to the from the code to the window. Now we're going to have some shader methods. So what is a shader exactly? So in OpenGL, we use the term shader to denote little programs that the GPU will run for each fragment it wants to display. So when we pass in code, or before everything, we send code to the GPU, and the GPU will run this little program. They're called shader programs. Every time we tell it to render something. So we will tell the position, where to put it, how to transform, what colors to put, what lighting to put, stuff like that. So this will all be done in the shader. And what you will notice is that the shader is much more efficient at doing stuff than the CPU, just because if you've ever heard of CUDA cores and you see like, oh, the new GTX or RTX 30 million has 15 trillion CUDA cores, well, that actually means that it has 15 trillion threads to run shaders on. So if there's a 15 trillion vertex object, it will run it in one instance, kind of, because it's multi-threaded. That's probably not right, but I'm not a GPU scientist, but it's probably close enough to how it actually works. Alright, so for the shader methods, we'll have to read a file. So return string, read file, and pass in a const char star file name. We'll have to generate a shader, so generate the specific shader, so generate shader, so int gen shader, const char star file path, and GLEnum type. Then we're actually going to have a function to generate a shader program, and this will be integer gen shader program, and we'll take in two parameters, const char star vertex shader path and const char star fragment shader path. So if you're wondering, well, what is the difference between gen shader and gen shader program? Well, there are two types of shaders in OpenGL that the GPU will run, and so there's the vertex shader that locates the position on the screen that we actually want to display the vertex at, and then the fragment shader path colors. It adds your colors, your lighting, all that, shadows, all that good stuff. So yeah, and then you link them together in a shader program, and that program will run each time. So we're actually going to be writing this code and storing it in files with our source code here. So that's how that's going to work. And for the cascading, the reason why I put there, not cascading, but the reason why I put the read file function above the gen shader program, which is above the gen shader program, is just because it's C++. Reads it from top to bottom, so the gen shader program needs to know that the gen shader function exists, which needs to know that the read file function exists. Next, we're going to have a function to actually bind the shader. So we need to tell the GPU, okay, bind the shader, because we're going to need to use it. So GL, and the parameter is GLUint shader program. Or no, sorry, that's integer shader program. Next definition is going to be to set the projection. So we're going to talk more about this, but all you need to know for now is just we're going to say void set orthographic projection, pass in an integer shader program, float left, float right, float bottom, float top, float near, and float far. So once again, I will be explaining what all this means. We're going to be constructing our own projection matrix when we actually write this code, so don't worry about this right now. And then the last shader function will be to actually delete the shader when we're done with everything. So void delete shader, and we're going to pass in an int shader program. Alright, next we're going to get into the vertex array object and buffer object methods. So the VAO and VBO and EBO are things that these are going to be our pipelines to actually send data to and from the GPU. So the shaders run code on the GPU, but the VBOs, the VAOs, and the EBOs hold the vertex data, the index data, this data, that data, all the data that the GPU will need to actually run a program, or to run a shader program successfully and send the data, put it on the screen properly, is through the VAO and the VBO and the EBO. So we're going to have a bunch of functions here, but we will first need a struct to actually kind of represent this. So VAO, so we're going to have a structure to actually represent the VAO. Alright, so I'm going to write the structure and then I'll explain it. So struct VAO, and then in here we're going to have a GL uint val, GL uint pose VBO, GL uint offset VBO, GL uint size VBO, and GL uint EBO. So what is all this? So the VAO, the vertex array object, is kind of the container for all of these other pointers. So on the GPU, it has a bunch of memory locations, and it knows what each of those memory locations, or it stores data at those memory locations, and each of these integers represent those locations. So the val will be the location of the VAO location, and the VAO is kind of this umbrella object that stores pointers to the VBOs, so the buffer objects. And the buffer objects are the things that actually hold data. So when we want to draw an object with its position VBO, its offset VBO, and its size VBO, we just have to say bind its VAO, make one call to bind that VAO, and the GPU automatically knows what data to actually look for. Oh, I should have said this before, but in this, I'm going to be saying the word GPU, and that's interchangeable with integrated graphics unit. So either one is, it works the same, or it means the same thing. It's just whatever piece of hardware the computer uses to actually render graphics. Okay, so these are going to be annoying to. These functions are going to be somewhat annoying to do. So first one is going to be generate VAO. So void gen VAO, and we're going to pass in a VAO pointer VAO, just like that. Next function is going to be a template function. So this will be to actually generate a buffer of a certain type and set its data. So template, and then in triangle brackets type name T. We're going to say void gen buffer object. We're going to say GL uint reference VBO, or BO, not body odor, buffer object. GL enum type, GL uint number of elements, T pointer data, and GL enum usage. Oh, I just screwed up in my reference. Next function will be to actually update the data in a buffer object. So this will be template type name T again, and it's going to be void update data, pass in a GL uint reference BO, GL int pointer offset, GL uint number of elements, and T pointer data. So this will be when we want to kind of update the data. So the offset and size VBO, these are meant to store the positions and sizes of different instances of an object. So when we pass this into the GPU, we might want to change it each frame. So this is where we will use update the data to communicate with the GPU once again. Next is going to be the set the attribute pointers. So I'll get into more detail when we actually write the code here, but these will just be tell the GPU how to actually read the buffer object data. So void set at pointer, GL uint reference, VBO, GL or BO, GL uint IDX, GL int size, GL enum type, GL uint stride, and GL uint divisor is equal to 0 by default. So once again, I will get into detail about what all of these are. Alright, a couple more, and then we'll actually get into some more exciting stuff. So, next we're gonna have a draw method. So draw using the VAO. So just void draw, pass in a VAO, GL enum mode, GL uint count, GL enum type, GL int indices, and GL uint instance count is equal to 1 by default. Next is going to be to unbind the VAO, or unbind a buffer. Yeah, buffer, not a VAO. So void unbind buffer, and we're going to pass in GL enum type. Then we're going to have a function to unbind the VAO. So void unbind VAO, no parameters. And then finally, we're going to have a cleanup method. So to deallocate the VAO and VBO memory. So void cleanup and pass in the VAO. And you'll understand why I only have to pass in the VAO later on. It has to do with the structure. Okay, almost there. Next we're going to have our main loop methods. So one will be to process the input. So void process input, GLFW window pointer window, clear the screen. So void clear screen, no parameters. I'm going kind of fast here, just because it's already been half an hour, so don't want to go for like 4 hours just grinding through this code. Next we're going to have a new frame, so void new frame, pass in GLFW window pointer window. And then finally we'll have our one cleanup method, so this will just be to terminate GLFW. So void cleanup, and we will write that after. Alright. So we've kind of outlined the process or the framework that we'll be building through. So we'll be calling these methods in the main method, and then we'll kind of insert the details on what happens at each of these steps, and kind of explain how it works, or how we can actually get this to render something. All right. So we can go ahead and start just by declaring a couple of variables. So we'll have some variables for the timing. So double dt is equal to 0.0, and double last frame is equal to 0.0. So these will be variables that will allow us to store the timing. So you know, just time in between frames, and you can calculate FPS with this stuff, but it's just useful for movement. Now we're gonna have our initialization. So, and all this is just call the method. So init GLFW, pass in 3 and 3. The version we are working with in OpenGL is 3.3. Next, we want to create the window. So we're going to initialize a pointer. So GLFW window pointer window is equal to null pointer. Then we're going to say call the method. So create window title, screen width, screen height, and frame buffer size callback, so the pointer to the method. Then we're going to say if not window, so if window is null pointer, it didn't create the window, so standard cout could not create window, standard end line. Then we're going to go cleanup, so just terminate GLFW, and then return -1. Next, we want to load glad. So so if not load glad, just print out some message. So could not init glad. Cleanup and return -1. All right. Now we're actually going to get into some of the graphic stuff here. So we're going to start with our shaders. So GLUint shader program is equal to gen shader program. Pass in main.vs, and we're going to create these files after we write this code. So main.vs and main.fs. And then we're going to say set orthographic projection. We're going to pass in shader program as the shader program. 0 left, right is going to be screen width. 0 for bottom, screen height for top. For near, we're going to say 0.0 float, and far is 1.0 float. So I'll kind of explain this now. So an orthographic projection essentially allows us to translate pixel coordinates into normalized coordinates that the that the shaders like to actually take in. So the shader wants normalized coordinates so that it knows what to display, how to display it, and then we apply transformations to it. And if correct me if someone can fact check me on this, but I believe orthographic projections are kind of the basis of all desktop applications. I believe that's right. Because if all primitive graphic engines are, in essence, I don't know if, I don't think this is right, but it kind of makes sense to me that all primitive graphic engines are OpenGL, stuff like that run directly on the GPU, so you have to go to that projection at some point in the shaders at some point. I'm probably speaking out of my ass right now. I don't really know, but it could be like that. So in a way, translating these pixel coordinates, so we'll pass in 400 400, and that'll display at 400 pixels, and that's kind of like creating a text box at some sort of pixel coordinate like you do normally with traditional graphics. So yeah, that's how this matrix will work, and we'll look at what it actually is. Alright, next we want to set up the vertex data. So for now we're just going to have float vertices array, and we're just going to create a box. So let's say we want, so we'll do 200.0 float, 200.0 float, and I'm just going to have an X and Y. Like that. So each vertex will just be represented and we'll type it in as a row, but we will tell the GPU to interpret each pair of values as a vertex. So 200, 200, then we'll say, what do I want to say? 100, or yeah, 100.0 float and 200.0 float, then 100.0, 100.0 float, then 200.0 float, 100.0 float. So these will be the vertices, and add a semicolon at the end. Oops, no, don't do speech recognition. So yeah, these will be the coordinates that we will pass into the GPU, and it will then translate it using the orthographic projection onto the screen. Alright, we also want to have an index array, so if we pass in the data properly, these indices will be, they will be read in as 0, index 1, index 2, and index 3. And what you will notice is that when we draw triangles, which is what you have to do in primitive graphics, we have to draw everything is based on triangles, because it's easy to draw for a GPU, because everything is on the same plane essentially. That it just makes it easier. So we need to draw it in pairs of 3. However, with a rectangle, if we have to draw that in triangles, you'll know that 2 of the vertices will overlap. So 2 of the corners will overlap when drawing with triangles, so we can kind of reduce the redundancy and just cut to the chase and actually just tell it which indices to draw in which order. Set up index data, so float or unsigned indices array is equal to, I don't know why it keeps formatting it like this. I don't want that. Yeah, there we go. Alright, so for the indices, we'll say 0, 1, 2, then 2, 3, 0. Yeah, that's right. So 0, 1, 2, 2, 3, 0. So you notice the overlap between the 2 and the 0 in both triangles. So the 0, 1, 2 will be the top left triangle, and then the 0, 2, 3, the 0, 1, 2 will be the top left, and then the 2, 3, 0 will be the bottom right. And we can actually, I forget how we do it, but you can tell it to draw outlines, and we'll see how that kind of works. Alright, now we want to have our offset and size array, so we're just going to say float, or you know what, yeah, let's make this as basic as possible. So go to the vertex array and change it to 0.5, 0.5, then negative 0.5, 0.5, then negative, negative, and then positive, negative. I forgot to do this, but so what this will do is when we combine this with our translation, our offset, and our size, we can kind of just generalize this to whatever we want. So we're gonna have a float offsets, and this will just be, we'll have one square for now, so offsets array, and it will just be 200.0 float and 200.0 float. So that's just one object, and then float sizes array will equal, then how big do we want this? And since we can kind of scale this up by whatever fraction we wanted. So we'll say, how do we want to do this? What size? Let's do 50 by 50. So 50.0 float and 50.0 float. So this data, the offsets and the sizes will be passed into the GPU via the VBO like normal, like these vertices here. And then in the shader, we will translate it and scale it up using this data. So this is just a general template for a square, and we can kind of size it up to make it whatever we want, whatever rectangle we want. Alright, now we want to set up the VAO and the VBO. Let me just put comments. Okay. Alright, so for the VAO, we're going to say VAO, so the structure name, and then VAO. Just, you can name it whatever you want. Then we're going to say gen VAO, so call the method, pass in a reference to VAO. Then we're going to set up the position VBO. So gen buffer object, template argument is float. We're going to pass in VAO.pose VBO. Then the type will be GL_array buffer. Then number of elements will be 2 times 4, because think about it, we have 4 elements here, and each of them, I'm just going to write it like this so it's clear what it is. So we have 4 elements and 2 kind of 2 data points for each element. So 2 times 4, then the actual data pointer, which will be vertices, and then usage will be GL, we're going to say static draw. So GL static draw tells the GPU, okay, this data will likely never change, so you don't need to place it in such an accessible location. Next, we're going to set the attribute pointer. So once again, this will tell the GPU how to actually read the data. So set at pointer, template argument is float, and once again, I will talk about the specifics of this when we write the source code. So for the arguments, it's going to be VAO.pose VBO. The index will be 0. The size will be 2. Type is GL_float. Then 2 for the stride, and then 0 for the offset. Next, we're going to, why is it not like this? Type name is, oh, I didn't even add the template. So for the set add pointer, make sure you have a template thing in there, just like that, because it's gonna handle with different types possibly. All right. Now for the offset VBO, we're going to say gen buffer object once again because we're generating a whole new buffer object. So template is float. So VAO dot offset VBO GL array buffer. 1 second, let me actually just handle something. I'll be right back. I just had this sudden urge to go take a tingle, so I'm sorry about that. Alright, where were we? Oh, we were doing the offset VBO. Yep, so the type is GL array buffer. Then for the number of elements, we're going to say it's one element, and there's going to be 2 floats per element, so 1 times 2. Then for the data, we're just going to say offsets for now. And then we're going to say GL dynamic draw for the usage. This is because, once again, you might want to use it. Oh, I didn't spell it right. Because so GL dynamic draw tells the GPU, okay, this is going to change often, likely every frame, so put it in an accessible location. Alright, so next we're going to say set at pointer, float. We're going to say VAO.size VBO, or offset VBO. Type is, or index is 1. This time size is 2. Type is GL float. Then 2 for the stride. Did I just straight up forget? Hold on, I think I forgot a parameter in that function. In set at pointer. Stride, oh I did. Alright, so in between stride and divisor in the at pointer parameters, add in a GL uint offset. I completely forgot that. So now set at pointer should read the VAO.offset VBO 1, 2 GL float, then 2, 0 for the offset, and then 1 for the divisor. So this time we are passing in a divisor, and it will become apparent as to why once we actually get to the code. Next for the size VBO. So gen buffer object, float is the template, VAO.size VBO, GL array buffer for the type, number of elements is 1 times 2 again, then offsets, GL dynamic draw, and then set at GL dynamic draw once again for the usage. Now for set at pointer, template argument is float again. Then we're going to say VAO.size VBO. Index is 2 this time, size is 2 again, GL float for type, 2 for the stride, 0 for the offset, and 1 for the divisor. Finally, for the EBO, so for the element buffer object, this will tell OpenGL what indices to draw in what order, so that's our index array. So we're going to say gen buffer object, the type is unsigned int, so VAO.EBO, then the type is going to be GL element array buffer, then for the number of elements it's going to be 3, where am I getting 3 from? Yeah, 3 because it's 3 indices per triangle times 2. I'm just going to make that evident. So 3 elements, or 3 data points per unit and 2 units. Then the actual data will be indices, and then usage will be GL static draw. Then we can go ahead and unbind some stuff. So unbind VBO and VAO. So unbind buffer, and the type will be GL array buffer, and then unbind VAO. Alright, now for the main loop. Damn, we are actually creeping on, or not creeping, we're taking way too much time for this. Okay, run to loop. We're going to say while not GLFW window should close. I'll pass in window, so this just gets the data should the window close or not. We're going to first update the time. So oh, okay, so here we go. We're going to say dt is equal to GLFW get time, that's a function, minus last frame, then last frame is equal to current time. or no, last frame plus equals DT. I'm sorry. Just a little trick there to reduce the amount of code. Next, we're gonna get the input. So process input, pass in window. Next, we want to render. So first, clear the screen. Then we're gonna say bind the shader program. Because once again, we want to tell OpenGL which shader we want to be run when we draw the object. So bind that shader. Then we're gonna call the draw function. So draw, pass in VAO. The mode is GL triangles. The count is 3 times. Wait. Oh yeah, the count for the number of indices. So this is the number of indices that we want to draw. So 3 times 2. Yeah, 2 triangles. Type is GL unsigned int. And instance count we can leave as the default. Oh, wait. Oh, indices pass in 0. And instance count we can leave as the default. And then we just want to swap the frames. So just call new frame, pass in window. And then outside of the loop, we're going to say, we're going to clean up some stuff. So clean up memory. So we're going to first deallocate the VAO. So pass in VAO. Then we're going to delete the shader. And then we are going to actually clean up GLFW. So clean up and no parameters. And then return 0. Okay. So that is the main loop. Pretty interesting stuff, right? Now we're actually going to be writing in the details of what each function should do and what it does, and we'll get into more detail. So this is actually going to be meaty stuff. I hate to say it, but it's going to be meaty as fuck. Holy crap! This might take a lot longer than I anticipated. But you know what? I have been skimping recently on the programming streams, so you know this is all payback. Alright, let's start it from the top. We are already at 219 lines, and we are going to make it 3 trillion by the end of this video. Alright, so init GLFW. We're going to say, call the function GLFW init. Then we're going to pass in some window parameters. So GLFW window hint. The hint is going to be GLFW underscore context underscore version underscore major, and we're going to pass in that parameter, so version major. GLFW window hint GLFW context version minor this time, pass in version minor. Then GLFW window hint GLFW underscore OpenGL underscore profile. And then we're going to say the value is going to be the core profile. So GLFW underscore OpenGL underscore core underscore profile. Next, we're going to have some sort of Apple specific things. So Mac OS specific parameter that just allows for forward compatibility on Apple devices. So that we're going to be using macros here. So if hashtag if defined underscore underscore Apple underscore, then GLFW window hint GLFW underscore OpenGL underscore forward compat GL true, and then end of. God, I've said GLFW VAO VBO so many fucking times. Oh my god, I'm gonna lose my tongue by the end of this stream. I just need to chill out and listen to the music. That's all. Okay, so for create window, I actually just need to chill. Like I'm stressing myself out too much. Okay, so we're going to say window is equal to GLFW create window, pass in the width, height, title, null for the monitor, and null for share. So this is the reason why we had to pass in a reference to the pointer, because we are setting up a new instance of the window and we are assigning it to the local pointer. So passing in a copy of the pointer doesn't change it back in the main method, so we have to pass in a reference to the pointer. Next we want to say if not window GLFW terminate, or wait, no, sorry, cleanup. That's, yeah, cleanup, and then return. Otherwise, we're going to say GLFW make context current window, then GLFW set frame buffer size callback, pass in window for the window, and then the callback is the frame buffer size callback parameter that we pass into this function. Alright, so for the actual callback, it's going to be simple. We're just going to set the viewport, so GL viewport. I actually forgot to do this up here. So in create window, we just have to say GL viewport 0, 0 width and height. I forgot to do that. Then in the frame buffer size callback, we're going to do the exact same thing. So GL viewport pass in 0, 0 width and height. So this function will be called at any time the window is resized. Then we're going to say SCR width is equal to width and SCR height is equal to height. So we're just updating the values. Then for load glad, it's going to be simple return statement. So return, then we're going to call a function that returns a boolean. So glad load GLL or GL loader. Then we're going to cast something to a glad load proc. And what we are going to cast is GLFW get proc address. So this is really ugly. It probably doesn't make much sense. So the reason why we need glad is because it's a library that just kind of links all the OpenGL functions to this program. So typically they're in a kind of hard to read format, so this just makes it a lot easier to actually read the most up-to-date OpenGL functions. Alright, now for the shaders. I'm going to try and blast through this because it's relatively simple. So for read file, this is something that we've done before. So standard if stream file, standard string stream buff, standard string ret is equal to an empty string. We're going to open the file. So file.open, pass in file name. Then if file.isOpen, we're going to read the buffer. So buff, and then two left triangle brackets. File.rdbuff. So we're passing in the buffer to the file buffer to the string buffer, the string stream rather. And then ret is equal to buff.str. And then else, we're going to say standard cout could not open, and then just pass in the file name. And then after the if else, we're going to say close the file, so file.close, and then return ret. Okay, next for generate shader. So we're going to say standard string shader source is equal to read file, pass in the file path, then const glchar pointer shader is equal to shader source.cstring. Then we want to build a compile the shader. So this will be one or the other. So the vertex shader or the fragment shader will be calling this method twice. So int shader object obj is equal to GL create shader, and we're going to pass in the type. Then GL shader source, pass in shader object. The count is going to be 1. The string value will be a reference to shader, so the GL char pointer, and then the length will be null. Then we're going to say GL compile shader, shader object. Now we can do some error detection here, so we're going to say check for errors. So int success, then a char info log array of length 512. Then we're going to call it OpenGL method to get the compilation status. So GL get shader IV, then shader object as the shader. The property name is GL underscore compile underscore status, and then the parameters is a reference to success. Oh, this is gonna be annoying to write. So if not success, you know what? I'm just fuck. All right, fine. GL get shader info log. Passing the shader object. The buffer size is 512. The length is null, and the info log is the info log that we created. And then print out the message. So file path, or no, not file path, info log, and then return -1, and otherwise return shader object. Now for generate shader program, we're going to be putting these together. So int shader program is equal to GL create program, then int vertex shader is equal to gen shader, pass in the vertex shader path, and then the type is going to be GL underscore vertex underscore shader. Then int fragment shader, same thing, is equal to gen shader, pass in the fragment shader path, and then GL underscore fragment underscore shader. Then we want to say if vertex shader is equal to -1 or fragment shader is equal to -1, return -1. Then we want to go ahead and link the shaders. So here we're compiling the shaders, and then we're going to link the shaders together. So GL attach shader. So attach. So the first parameter is shader program, and the second parameter is vertex shader. And then the second line is going to be GL attach shader, shader program, and then fragment shader. And finally, we want to say GL link program, and just pass in shader program. Holy crap, my jaw is just numbing. I hope my jaw just isn't completely done. Whew. By the time this is over, I hope I can get through this. Holy crap. Alright, and then we want to check for linking errors this time. So you can copy and paste the error check over here. Just paste it in and change the parameters in GL get shader IV. So it's going to be GL get shader IV. Pass in the shader program this time. And the property will be GL underscore link underscore status. And then to get the info log, it's just get the shader program as well. And you can change the message as well. And then finally, we want to delete the shaders because they're already linked and already compiled, so we don't need to actually use them anymore. So GL delete shader, vertex shader, and GL delete shader fragment shader. and then return shader program. Holy crap. Oh, Jesus. Okay, for bind shader this time, we're going to say simple one line, GL use program, and we're going to pass in shader program. Alright, now for this is just to tell OpenGL, once again, I've talked about this, just set the current shader program to this one, so it knows which program to use to actually know what to do with the data. Alright, so now we're going to do orthographic projection. So we're going to start with a float matrix 2D, so 4x4. So I'm just going to input the values, and I'm going to input a 4x4 identity matrix to start. So 1.0 float, 0.0. So I'm just creating an identity matrix. If you don't know what that is, it's simply just a 4x4 matrix with ones along the diagonals. I should probably link the math video where I talked about this. Yeah, I will. But yeah. God, that was so long ago. Holy shit. Okay, so this identity matrix, I should probably release another video because I've learned a lot more since. But anyway, this identity matrix will not change anything. So we need to input values based on an orthographic projection matrix. And this is the Wikipedia page. It's pretty simple. Although there is something weird here. So this matrix tells us that these three values should be on the right. However, this didn't work for me. I had to put it on the bottom row. So I will try to figure out what actually happened there, but I don't really know. So maybe I'll find an explanation. But anyway, so for the values, we're going to start at the top left. So the top left 0, 0 should be 2.0 float divided by, and then in parentheses, right minus left. So I'm actually just going to put a link to this. I'm actually going to put it in the video description as well. Where am I? Here we go. Alright, so it should be up to date now. Oh, this is the best one. Even though it has depression in the title, it's still the best song in this album, in my opinion. Okay, so once again, 0, 0 is 2 divided by, then on the bottom, right minus left. Then in 1, 1, we're going to say 2.0 float divided by top minus bottom. Then in 2, 2, so in the third one on the diagonal, we're going to say negative 2.0 float divided by far minus near. So that negative, I didn't study too much up on this. I don't know why this is negative and these are positive. I think it just has something to, it has something to do with the math here. Don't ask me. I will try and understand it, and I might do something, talk about it in the next time. Okay, so you can kind of think, or wait, is this even right? Yeah, that's right. So you can kind of think of these as like the reciprocals of the averages. Averages? No. Wait. Oh, I don't even know what I'm talking about anymore. Yeah, so these three are the scaling values. So these are used to scale it, and if you multiply this matrix by the vector position, you will get that this scales it properly. And then we're going to have the translations on the bottom, which, is what I was a little confused with, but that's how it works out. So on the bottom row, we should have negative, then in parentheses right plus left, then divided by in another set of parentheses right minus left. Then the second element should be negative top in parentheses top plus bottom divided by top minus bottom, so you kind of see the pattern. And finally, in the third column on the bottom row, we're going to say negative in parentheses far plus near divided by far minus near. So I should probably put this code somewhere on like Pastebin or something, but for now that's what it is. I'll give you guys a second to write that down. Okay, now in order to actually set this up in the shader, we're gonna first have to bind the shader. So bind shader, pass in shader program, and then we're gonna use something called uniform variables. So in each shader, you have the option to pass in some values to the shader via a uniform variable. So these will be from the CPU. So you can just set specific values to what you want. So we're just going to say, to set a matrix, we're going to say GL uniform matrix for FV. So there's different methods for different values. Then for the location of it, we're going to say GL get uniform location. The program will be shader program, and then the name will be projection. And then the count will be 1, transpose will be GL false, and then the value itself will be just mat. I believe that works. No, it doesn't. So we just need to say a reference to mat at 0, 0. Or whatever you named your matrix. Alright, and then one thing I wanted to do with this actually is when we change the window size, I want to change the orthographic projection as well. So what we're going to want to do is in the callback here, so in frame buffer size callback, I just want to update the orthographic projection matrix. So at the bottom we'll say set orthographic projection, pass in this actually won't work. So we need to, we can just make shader program a global variable. That's fine. Where is it? So if you don't have to do this if you don't want to, but I'm just going to make shader program a global variable so we can actually access it in the callback. So in the callback, just go ahead and say set orthographic projection, pass in shader program, 0 right will be the width, bottom will be 0, top will be the height, and then near is 1.0 or near is 0.0 float, and far is 1.0 float. Alright, so now onto the source code for the VAO and VBO stuff. Luckily, or wait, no, we're not even there yet. I'm sorry. Delete shader. Simple. GL delete program. Shader program. Alright, now for the VAO and VBO stuff, this is going to be a lot easier to write than it is to, or a lot easier to explain than it is going to be to write. So for gen VAO, we're going to say GL gen vertex arrays 1, and then a reference to VAO dot val, and then we want to bind it. So GL bind vertex array VAO dash val, or dot val. But because it's a pointer, you just replace the dot with a dash and then greater than sign. Alright, next for the generate buffer object, we're going to say GL gen buffers 1 for the count, and then a reference to BO, then GL bind buffer, and just pass in type and BO. Then we want to set the data, so GL buffer data, pass in the target is type, the size is going to be number of elements times the size of t, so the parameter argument, then the data will be data and the usage will be usage. So data is just a pointer to the data that we'll be passing to the GPU, and usage will be dynamic draw or static draw or stream draw, which is kind of in the middle of the two. Now for update data, we're going to be saying GL bind buffer again. The target will be GL array buffer, so I'm not going to pass it in as a parameter this time, because GL array buffer will be the only buffer object that we'll be modifying, and then BO for the buffer. Next we want to say GL buffer sub data, so this will allow us to actually change the data. So say GL array buffer, then the target is offset, or sorry, offset is offset, so just like the offset in the data pointer. The size is number of elements times size of t, once again, and then the data is data. Now for set attribute pointer, we're going to bind the buffer once again, so GL bind buffer, GL array buffer, and BO. Then we're going to set the vertex, what's called the vertex attribute pointer. So GL vertex attrib pointer. So we're going to go through this parameter by parameter. So index, this will be the index of the data. So the index of the data stream, or the data point, or how do I want to say this? So the index that the shader will be accessing this data from. So IDX, then the size will be just the size of each unit. So size, or the number of elements per unit. Then the type is just type, so float, unsigned in, whatever. Normalized, we're going to say GL false. Just don't worry about that right now. For the stride is just the size in bytes of the distance from one element to the next, or the one unit to the next. So stride times size of t, and then the pointer will be a reference to void star, or sorry, not a reference. We're going to be casting offset times size of t to void star. So this, the last parameter should read void pointer in parentheses, and then in another set of parentheses, offset times size of t. And then we want to enable this, so GL enable vertex attrib array IDX. And then we want to say if divisor is greater than 0. So what does the divisor means that we're going to be resetting the IDX attribute every divisor iteration through the instances. So if we choose to draw something using draw elements instanced, what that means is OpenGL will go through the data and it will draw the vertices properly, and then it will reset certain attributes every instance. So that's where our size and offset buffers come into play, because we want to reset these every instance. The vertices we just want to iterate through properly. We just want it to go this vertex, next vertex, next vertex, and so on for the whole object. But we don't want it to iterate through each size and each offset each vertex. We want it to iterate through one per instance. So by telling the GPU reset it every some sort of iteration, then we can tell it, okay, in this object, take the first one, then in the second object, get the second one, and so on and so forth. So the way to do this is just GL Vertex attrib divisor, pass an IDX for the index of the attribute, and then divisor for the number. Alright. Almost there. I think that was the last of the thick code. Yeah, it was. Alright, thank fucking God. Holy shit, my voice is gonna die. Okay, for draw, we're gonna say GL bind, GL bind vertex array. Then just the VAO.val. I hope that's the last time I have to say that. Then we're going to say GL draw elements instanced mode. So the GL triangles, like we said, so the mode that we want to draw on. Count for the number of indices to go through. So we're going to be using GL draw elements. So there's a different one, draw arrays, draw elements. Just allows us to use the EBO so that we can kind of index through it. Then the type will be the type, so GL unsigned int for the indices. Then the indices, we're just going to pass in a cast the parameter indices to a void pointer. And then for the instance count, just pass an instance count. So if we wanted to have, let's say we were in Pong, we're going to have 2 paddles. So we want to have 2 instances of a paddle. So therefore we will pass in 2 for the instance, and then it will reset the offset and the size in the shader every instance. So for one instance, or for one paddle, it has a certain offset and size, and then for the next paddle, it has a different offset and size. Now for unbind buffer, we're going to say GL bind buffer type and 0. Now for the unbind, oh fuck, my jaw fucking hurts saying that. VAO, God, it's so painful to say it. GL bind vertex array 0. So this is just clearing the bound objects in the GPU, freeing up a little bit of space. Alright, now for cleanup, oh, I gotta say it a couple times here, great. GL delete or buffers 1, then a reference to VAO.pose VBO. GL delete buffers 1, then a reference to VAO.size VBO. Or offset VBO rather. GL delete buffers 1, and then a reference to VAO.size VBO. GL delete buffers 1, and then a reference to VAO.EBO. And then the last time we're going to say it, GL delete vertex arrays 1, and then a reference to VAO .val. Holy crap, I don't have to. I think I don't have to say that anymore. Oh, thank the lords. Alright, we're done. Or no, we're not done. Four more methods. Process input, simple. If, sorry, I'm going to take a break for a second. I'm going to get a sip of water. Oh God. I need to stretch my jaw. Jesus Christ. Okay, let's finish this off. We got 4 more. Let's finish strong. Okay, if GLFW get key, the window parameter, and then the key, GLAD actually provides us with a bunch of these enums. So we're going to say GLFW underscore key underscore escape. So just the escape key, we will bind it to the window closing. So if that equals GLFW underscore press, GLFW set window should close, window and true. So this will stop the loop. So once again, our main loop depends on GLFW window should close, and if that's true, then this while loop evaluates to false, so it runs out of the loop, or goes out of the loop. Clear screen. We're going to say GL clear color. You can put any random color here. I'm just going to put it for black, so 0.0 float, 0.0 float, 0.0 float, and then 1.0 float, because that's your classic Pong background. And then for new frame, we're going to, and I almost forgot, after GL clear color, we're going to say GL clear, GL color buffer bit. I forget exactly what this does, but in the documentation it probably states it. Okay, so for new frame, what we want to do is kind of swap the frames, because what OpenGL does is it generates the next frame as it's displaying 1. So as it has one frame out, it's generating the next frame. So what we want to do is in the new frame is just swap the two. So GLFW swap buffers window, and then GLFW poll events, and poll events just updates all the GLFW get key, all that stuff, checks for signals from the keyboard and stuff. Okay, for cleanup, we're just going to say GLFW terminate. And that's it. I think we're done. Whew. Are we going to beat the album? I doubt we will. Oh no, we will. We will. We're going to play around with it now. Alright, so let's run it. And I hope... fuck. Oh, right, because set orthographic projection is not defined up here, so... Right, so in the callback, it just doesn't like set orthographic projection, so I can probably just move the frame buffer size callback to main method loops, or main method functions in that section, just to make it simple. And it kind of goes in with the main method loops, or the main loop methods. Alright, so now let's run it. Oh, cleanup identifier not found. Alright, what's this? If not window, okay, cleanup, it doesn't like it either. So we just replace in create window, just replace cleanup with GLFW terminate. Or wait. Oh, I don't even think we need to, because we just clean up. Oh yeah, we're fine. Just delete that. Delete the cleanup call in create window, because we already do it on IL6. No, not on IL6. In the main method here. So if window is returned as null pointer, we simply just terminate the GLFW. Alright, now let's run it. Fuck. Oh, there's a glad error. Oh, I didn't even drag glad. Oh, right. So what you need to do is include glad.c in the DLL file in the project. Okay. Now we should be good. Yes. Fuck. At least it got up there. At least there was something. Okay, so what is it not like? Create window. Alright, so the viewport, maybe if I just comment out the viewport, it'll be okay. Oh, right, because it hasn't loaded glad yet. Okay, that's fine. So comment out the view. Okay, it could not load. Oh, stupid me, I didn't even create the shaders yet. I just completely forgot. Okay. Yeah. Okay. Okay, so one change is put the viewport call into the main method after we load glad, because like I said before, glad kind of gives us access to all these libraries. We need to load in glad first. So after load glad, just set the GL viewport and pass in screen width and screen height. Okay, now we need to do the shaders. I completely fell out of my mind. Alright, so just create new files. You can do text files. So I need to get my code up here. So we're going to start with the Vertex shader. So the shaders are written in language called GLSL, and it's kind of like C, except there's just a couple different keywords, not many different syntactical aspects, but it looks a lot like C, but there is a little difference to it. So we're going to start with our headers, which is like a macro. So hashtag version 330 core. So this must align with what we put in initialize GLFW. So major version 3, minor version 3, and core profile. Then we want to say we're going to get our VBO data, so layout, and then this is where the indices come in. So location is equal to 0, in vec2 pose. So what does this line mean? So layout, go to the layout that the VBOs have set, get the 0 width attribute, and then take it in as a 2D vector and call it pose. Then we're going to do the same thing. So layout, go to location 1, take it in as a 2D vector size. Then layout, go to the second location, take it in as a vector 2 as a 2D vector, and call it offset. And then next we want to have our projection matrix. So this time it's a uniform variable. So we're going to say uniform mat4 projection. So this tells the shader, okay, take this value from the uniform values. And then the main method is the same thing as C, but it doesn't return an integer. So void main. And then we're going to call a reserved word, so GL_P position is equal to projection times, and then we're going to say in vec4. Then we're going to, for the first two parameters, here. So GLSL is really good with vectors so that you can kind of pass in, and it just makes a lot of sense. So let me just write this. So for the first parameter, we're going to say pose times size, and then plus offset, so that's just the scaling and translation. Then for the second parameter, 0.0, and then for the third parameter, it's 1.0. So what does this line mean? It shouldn't have 4 components? Well, yes, but GLSL, like I said, is very good with this. So it interprets this 2D vector as 2 parameters. So it takes the 2 arguments and then just passes it in as the first 2 values for this 4D vector. Let me just turn this down real quick. Yeah, so it's the end of the album. Oh, it's so unfortunate. Yeah, so then 0 for the Z coordinate because we only want 2D stuff, and then 1.0 for the W coordinate. That just has to do with the translation stuff. So I probably should make another video on the math around this, but that 4th component is necessary to make the translations proper. And then this GL position here is a reserved word, so GLSL interprets this as something that's already declared in memory and tells OpenGL, or tells the GPU, okay, this is the position that we want to render a vertex at. All right, now you can go ahead and save this in the just save it with the source files and just call it text main.vs for vertex shape. All right, just like that, and then we're gonna do the same thing. So I'm just going to rename it as, or I'm just going to copy and paste the file essentially. Oh, cancel. All right. So I'm going to include this, and then I'm going to just copy and paste the file in my file explorer, just so we don't have to do the same thing again. So copy, paste, and rename it as main.fs. Alright, so reload, include the fragment shader, and now open up the fragment shader, and it's going to be somewhat similar. So we're going to say hashtag version 330 core, so same macro. This time we're going to say out vec4 color, so we're going to be outputting a color here, and then we're going to say void main. And then we just want to say color is equal to vec4 1.0. So we're setting all the components to 1, so it's going to be white. Okay. Now let's run it. And Ooh, fuck yes. I'm sorry if you guys had headphones on, but it works. Wow. Jesus Christ. 84 megabytes. How the fuck does that work? Alright, we're done now. That's Pong. If you didn't know, okay. Let's play around with this. A little bit. So let's go into the main method. And let's try moving this object around. Or, let's do this in process input, rather. So what I'll need to do now is... if I want to use keys to kind of do this, I'll pass in offsets and sizes into the process input. So in process input, just add 2 parameters, or just the sizes for now. So just add a parameter float size or offset pointer, and then we're gonna say we're just gonna test for the arrow keys. Let's say so if GLFW get key window and then GLFW key up, let's say up, does not equal GLFW, or yeah, GLFW up, key up. Oh wait, no, does not, or is equal to GLFW press. We'll run into an error here, or not an error, but a logical error. So if it's equal to GLFW press, we're gonna say offset at 1 plus equals 1.0 float. Then if GLFW get key window GLFW key right is equal to GLFW press, offset at 0 plus equals 1.0 float. Alright, it's done. I'm going to just do this for the other 2 directions as well. So if GLFW get key window and GLFW key down is equal to GLFW press, offset at 1 minus equals 1.0 float. And if GLFW get key window and GLFW key left is equal to GLFW press, offset at 0 minus equals 1.0 float. Okay. So now in process input, we'll pass in the offset array, and then offsets rather. Okay. Now since the data's changed, how are we gonna update this in the GPU? So to update the data, we just call that function. So update data, pass in the template argument as float. The buffer object is going to be VAO dot offset VBO. The offset is 0. Number of elements is 1 times 2. And then the data will be offsets. Alright, so now let's run this. And I'm going to be pressing my keys. Doesn't like something, what's happening? Okay, why did it just jump up to that much fucking memory? Whoa, holy shit, that's not right. It's stretching stuff out. What? This is scaling. Why is it scaling this? Did I screw up in the Vertex shader? I'm just going to create a breakpoint here when I press the up key so I can see what's happening. Alright, so offset 200. Offset at 1 is 201. Okay. Clear screen. Alright, now offset is 200, 201, but so it's doesn't like the, so this transformation is wrong then? Let's check this out. Main.vs. So we multiply the projection matrix times this vector, which has position times size. Oh, because I screwed up the location. That's right. Okay. All right, that makes more sense. So offset should be location 1 and size should be location 2. That is right. That's completely my fault. Because I changed up the location of my reference to now. So yeah, I just made that mistake. So it does matter. So it was multiplying it by the wrong thing and then adding the wrong thing. So now, fuck, I add the breakpoint. Continue. Yeah, yeah, fuck yeah. Woo, it's moving. How does it jump to 84 megabytes? I'm really confused as to why, and you can just let it go off the screen. Ooh, never to come back. I'm just gonna let that go forever. Okay, I'm actually done. Fuck, I'm tired as shit. Alright, so it's been fun. Just a quick recap. I'll add this in the description, but we kind of built ourselves a bare bones engine here. Very simple. And it's turns out this is all we need to create Pong. Not beer pong, Atari Pong. So exciting stuff in the future. And we will we'll get to it. Hello. I hope I'm pronouncing this right. Shanmuka Sadhu. I'm hoping I think that's right. But anyway, yeah, you caught us just at the end. So yeah, quick little Pong. This is the beginnings of a Pong game. But yeah, 2D, pretty fun. And I'm just gonna say one more note about this projection stuff. So I didn't really talk about it, but this is the matrix that we multiply the coordinates by to translate it to a screen or to values that the shader likes. So the shader will like to kind of print or display values that are normalized. So we pass in pixel coordinates and the projection matrix. When we multiply it by the coordinates, it becomes normalized. And yes, I am making a Pong game. This is just the beginning though. It's been 2 hours, so I'm almost dead right now, but this is our result as of now. So it looks a little bit like it. So yeah, next time, probably next week, I don't know. I'm going to be expanding upon this. We'll probably add we'll add all the objects in. We'll add a circle object in, how to do that. And then after that we'll be getting into collisions, physics, and it's actually a lot simpler than in 2D, since it's 2D and not a friggin' nightmare like we did with the Octree and 3D. Holy crap. But you know, it was satisfying to get that done. But anyway, hope you guys enjoyed the damn, it's been a while since I've done something this long. But anyway, hope you guys enjoyed it, and I will see you next week, probably, when I continue this stuff. So yeah, I will see you then. Adios.